Hello guys. So I do have pretty much little time because we have long electricity shutdowns here in Ukraine. So as I announced, I started making my all-in-one plugin, and as I started my channel 2 years ago, this plugin also started with the dynamic weather system. Particularly this tutorial is the part 1 of the series, and I'm gonna cover advanced day cycle with the moon phases and stars. To get the project settings for this tutorial, you may follow up to my Patreon and subscribe to the tier 1 or tier 2. So let's start from the scratch, right? I do have the blueprint actor which I placed on my scene. This one. On your left you may see essential components that should be included to have this feature pretty much realistic visual feedback. So we start with the sky atmosphere, and this component can work with two directional lights, sun and moon respectively. For sun, here I have the source angle of 1, intensity of 3. This one also has cast cloud shadows. That means that if I have the volumetric clouds on my scene and my sun is covered with them, I will have the actual cloud shadow. Next thing is to what? Yep. Once you have the sky atmosphere added, here in the directional light you should select atmosphere sunlight checkbox. This will help you to get the proper sunset and sunrise scattering effect. The same for the moon. Also, you need to select index of 0 for the sun and index of 1 for the moon up here respectively. So next to the moon phases that I'm gonna calculate in the shader, and also this one will help us to separate the lighting influence on the scene. For the moon, I do have source angle of 0 and intensity of 0.5, because at night we don't have pretty much bright scene, and source angle we don't need to have the actual sun disk, default sun disk, because we're gonna change it to the proper static mesh component with the moon shader up here. Also, moon can cast shadows, but the amount of shadow should be set to smaller one, so we don't see too dark shadow. This one can be done only if you have the old shadow system. So go back to your project settings. In the rendering tab, here you need to have the shadow maps method, because without this one, the new one, virtual shadow maps, simply doesn't allow us to get control over the amount of shadow on the scene. So next one is to add skylight, and I don't have anything changed except of the real-time capture. This one is kinda cheap, especially with the Unreal Engine 5, and this can help us get rid of the cube maps and all the actors, props and so on that we have on our scene. We'll get contribution from the actual time of day, so that means that we have the proper reflections and sunset and sunrise tinting effect for the shadows and for the actors also. So next one, I guess, volumetric cloud. I didn't change anything except the layer. So altitude here stands for the distance from the ground at which our cloud appear, from 1 to 20. Height here is for the depth or the width of the actual cloud. So 1 is for the narrow and we can see through them, up to 20 to get these fluffy and heavy clouds. Material here is by default, but I'm gonna change it to the new one in the next tutorial. Next one is exponential high fog. Fog and scattering color I set to be gray to have the smooth and pretty much better transition between the ground and the sky. Also, volumetric fog checkbox is selected. That means that with this one and the sky atmosphere together, I get contribution from the sky atmosphere, so if I have the sunrise and sunset, my fog would not be only this gray color, but it will get the tint from red to orange on those time of day events. So next, as you can see, it's the post process. I have overwritten only two attributes, it's the bloom intensity and the exposure. If exposure has two different values, this will enable the eye adaptation effect. Bloom here I set to lower, just it's the matter of taste, because I don't like to have too much light when I look towards the sun on the moon disk. You may also see that here I have the priority of 0. That means that if I have the external post-process volume on my scene, I can override values from there instead of this blueprint actor. We have few things left here before we actually start. So you may see that I have Niagara system, it's for the stars. You may create your own one here and leave it empty as the placeholder, so we can talk about this a little bit later. And actually the moon model, it's the static mesh component attached to the directional light. Because we're gonna actually change the rotation of the directional light to have contribution to the ground. Once our mesh is the child of it, it will inherit its movement. I'm using the default engine sphere with the moon shader. You may leave it also empty right now, but you need to change the scale and location. You may see that the size and location is actually kinda big numbers, because everything up here is measured nearly as in realistic life, right? Because, for instance, our clouds, high and the distance is measured in kilometers, and overall thing is here. We have the radius of our Earth like 6,000 kilometers and so. So think about this as the layer cake, right? We have the bottom layer of our clouds, then we should have moon, and then we should have stars. So if the clouds are narrow and we can see through them, we can see the moon and stars. And if we have them heavy, we don't see moon and stars also. So that's how the order should be done. So that's why we need to have pretty much high values for our size of the moon and its location. The same goes for the location of our stars. Because my stars are made of the Niagara, the actual sprite size and the distance is done inside the Niagara system, but they are also high values. One little moment is that sun, moon and stars, they all share the same kind of direction. And all of those components in real world, their rotation begins from the east to west. So that's why for our moon up here, the location is minus x-axis. So now let's talk about calculating the proper day length. Here I have the separate function, compute current time, which execute on the tick event. You may see that I have two different temp variables, one for the day cycle, other one for the moon cycle. The reason is that moon is kind of slower than the sun. So for sun, if we need to have the full circle, it requires 24 hours. For moon, nearly 25. You may check it on the internet yourself. How to make it work? Delta second divided by the following equation. Day length is measured in minutes. We multiply by 60 and divide by 24. Then we add it to day cycle and moon cycle hour respectively, and store them to the temporal variables. We need to have them here as a global one, so we can get those values outside this function, but to have the whole thing a little bit more cleaner, I use those variables. Next thing is to actually clamp the values from 0 to 24, and in terms of the moon from 0 to 25. So I have select float, where I measure if the 10-day cycle is less than 24, I go with the same value. But if it's false, it comes over the 24, I use apps with the following equation: 24 minus the 10-day cycle. The same, but with a little bit higher, 25, comes for the moon cycle. So next one is this big and scary function, which stands for actual sun and moon rotation and their position on the sky sphere. This function is called update sun moon position, and it has the input of the float, which is called sun height. Sun height stands here for the actual highest angle at which sun and moon appear at noon. And this one depends on the season. So in winter it's the lowest, and in summer it's the highest, which leads to the following: that the sunrise and sunset can be shorter or lower, I mean the time where they appear. And here I have the enumeration, which looks like this: spring, summer, autumn and winter, and the predefined selection. Those values are an angle on the y-axis for the moon and sun directional lights. Here it's the pitch axis. On the construction script I also have this function called, so I can have the, like set up the whole scene and see the visual feedback before I start the actual gameplay. Let's take a look at this image one more time. Here on the left you may see that the actual path for our sun and moon is not straight vertical but slightly diagonal. For one angle on the z-axis it takes up nearly to 3 degrees on the y-axis. Y here stands for the position at which we have sunset and sunrise. We don't really care about the full circle, so we can start and end with the same position. We only need to have the proper whole circle rotation on the z-axis. This one happens on the clockwise, like this. If you place any actor in Unreal, it will look towards the north, so that's why that rotation begins with -90 and ends up to the 270 degrees. That's the actual length of the circle at which we can actually see sunrise and sunset. So back to our function. Here I have two separate set world rotation events for sun and moon. Calculations here are nearly the same, except moon cycle is 1 hour longer. Check the values yourself. So here and here I divide the cycle up to 4 periods for 6 hours per period. And each period has, like a ping pong function in a range between 0 and 1, 1 and 0. Depending on those alphas, I decide whether I go with this calculation or this. This calculation is for the day time, this one for the night time. So here is the picture. If it's sunrise up to the noon and from noon to the sunset, I select this part. And calculation only include this sunrise value. But if it's evening up to the early morning, I select the second part of the lower globe, and I use this calculation, 360 minus the sunrise. Sunrise here stands for the y angle at which sun or moon start their rotation. So this one is the sun or moon rise angle, y angle. Here we have interpolation with the easing, and this value is for, like making it from straight linear to exponential interpolation. This part, depending whether it's the day time or the night time, select between those functions, those calculations. The same but a little bit easier calculation comes for the yaw rotation. So we have the full circle. The day cycle is normalized between the values, so it also returns 0 to 1 range. And here we have the coefficient for exponent interpolation. So guys, here I made it a little bit easier to read, and I placed my values here that you may check them. So guys, let's talk about stars. This is kinda simple but yet effective material. You may use your own. Blend mode is set to be translucent and shading mode is unlit. To make the proper sorting, here with the volumetric clouds you need to look after apply cloud fogging. Without this checkbox selected, you'll see your stars appear before the volumetric cloud. Emitter of my stars. I've created empty one, but then added few modules. First of all, select properties and go with the GPU simulation. Next, set fixed bounds. The higher value is, the more wider angle you need to clip the system off the screen. Next one is emitter state. You should go with self and loop behavior set to infinite. Once it's infinite, you can deactivate emitter via the blueprint. Loop duration set to the day length. It's the custom variable that I'm gonna set via the blueprint. To make your own, please select the plus up here under the user exposed and define the name. The system will work depend on the proper date time, so our stars will appear at the specific period. Next module is spawn burst instantaneous. Here we define the spawn count per loop, and loop count has the limit. The lower limit is, you may check this diagram. So what do we have here? We have two different systems. Let's say we have time, and there are periods where stars start appearing on the sky sphere, and then we have the period where they are at the amount that we cannot count. So let's say they have the fixed amount and it's the still period. So if the loop count is high enough, it means that we're gonna spawn our stars slower. But if the loop count is low enough, we'll spawn all of our stars faster. Something like this. So, next one is initialize particle. Lifetime set to be the accusation by multiplying the number of loops. You may see that we have 8 up here. It's the same amount always as we have at the spawn burst instantaneous up to here. And the day length. With this setup, it means that once we have the system deactivated, each portion of particles that was spawned will be destroyed at the same exact behavior. The earlier one will be destroyed earlier. Sprite attributes up here, the size is kinda big. As I told you at the beginning, all the system dimensions are kinda realistic. We need to have the size also big. So that's why I have the random uniform with different with the different values. It's 2500 up to 7500 to simulate the actually behavior when we have stars that are far from us and maybe bigger or smaller, and the one that are closer to us. Next one is the shape location, and it's the sphere, because we need to have sort of the sky sphere or the star dome. Sphere radius is kinda high. and it's a little bit higher than the radius of our, not the radius, but the distance at which we start our moon positioning. Distribution is said to be random, but the value is 2. Values between 0 and 1 will emit particles inside the sphere, but values from 1 up to infinite will actually distribute particles from the surface to the infinite. That's why we don't have the intersection with our moon and stars. Hemisphere is 1 and 1 because we have the specific amount of particles spawned, and we have the rotation. We don't need to respawn our particles, it's just the cycle. What else? Here we have nothing. Next one is the particle state. By default you have this one, and we need to deselect the default checkbox and go with the two following: loop particles lifetime and leave left infinite lived particles die when emitter is deactivated. Next, rotation is the vortex velocity. Here I have the acquisition with the following: divide float, where I define the force divided by the day length. It means that if I have the day length of 1 minute, the rotation would be kind of fast. If the day length is 60 minutes, the rotation of the stardom will be slower. Here we also define the axis, and because we should start with the east to the west rotation, the x-axis is 1 and every other dimensions are 0. To make it also work, you need to have solve forces and velocity module. Without it, vortex velocity just won't work and your particle won't compile. And for sprite renderer, I simply have material of my stars. So, next one is to define the function inside the blueprint to set the user variable for your Niagara system. Mine is called init Stardom and it looks like this. Variable name doesn't need to have the prefixes anymore. I call this function twice, once on the construction script, just to have the visual feedback of my stars. So I'm setting up the scene, other one on the event begin play. It has fancy setup, more for participation purposes. I like to have my Niagara systems attached to my player pawn. You know, it's for the indoors and outdoors particle collision stuff. So once you've attached your Niagara to your player pawn, if you have the vortex orbit module, you need to rearrange or to override the rotation rule for your Niagara system. In terms of you have the third person character template or the game, if you change the direction of your camera or your pawn, the system should have the unchanged the rotation mode. So that's why I use set absolute up here for my stars with a new absolute on the rotation. So the last part for Niagara is actually toggling on and off the stardom depending on the period of day. So we define the new function. This one is pure because it doesn't calculate any, except it just returns the value. I've made another enumeration. It's part of day. We have morning, afternoon, evening and night. Here we just check the in-range conditions. So whether it's 5 to 12 it's morning, and so on and so on and so on. Then, because everything, like all the checks should be done on the tick, because you know it's like it was 5 o'clock, now it's 6 o'clock. We need to check whether we should show stars or make them disappear. But you don't need to override the current state every time, whether it's show, 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 then hide, hide, hide. You need to simulate kind of do once event. So that's why I have this custom event. We check whether we have the show stardom. It's my boolean that I created. If it doesn't equal the night, It means we can proceed. Then, if we can proceed, we simply check whether it's night. If it's night, we're gonna show Stardom. If it's not, we're gonna hide Stardom. And that's simply how it is. So each of them will fire only once in a tick. So guys, moon phases are last to cover. On this picture you may notice the following behavior. As you know, Sun and Moon both share the same direction. As Sun is faster than the Moon, with each day Sun is ahead of the Moon, right? And the distance between them increase. So that means that the Moon starts growing from the new Moon up to the quarter till the full Moon. But when the distance between them starts to decrease, it means that the Sun tries to catch up with the Moon, so the Moon is ahead of the Sun. It means the Moon starts to getting older, so it's decreasing. So this one is the shader that you need to implement, and that's it. Basically, you need to have the dot product between Sun atmosphere light direction with the index of 0 that goes for our Sun, and our model vortex normal world position. Then you need to saturate this mask, so you have the values between 0 and 1 and multiply it by the emissive color. Apply this shader to your moon model and then check this out. So you may see that moon and day cycle hours are nearly the same, so they share the same position, and that's the new moon. But once the Sun becomes ahead of our moon, we have the new moon up to the quarter, so the moon is growing until we have the full moon right here. But once the Sun is catching up with the moon, you may see we have the moon decreasing. So that's how it works. That's it for this tutorial, and I really hope you like it. As always, please subscribe to my channel, advertise me as much as you can. I do have Patreon page, and you may find the link under this video. Guys who support me right now, you're just great. We have really harsh times, and yeah, I'm really thankful for you. Probably I'll see you next week, but it depends on the circumstances, so just stay with me and yeah, see you around.